All right. Now we're going to move into the periodic motion section of the exam. We've reviewed pretty much all the stuff we could do for circles. Well, there's more we could do for circles, but, you know, it's a good review. So the highest point on a wave, let's just go through and label the highest point on the wave. That's the crest. The lowest point is the trough. These are names, but we got to learn them. So the distance from one crest to another is the letter is lambda, the word is wavelength. Now, V. Frequency is a measure of number of waves per second. And let's go ahead and label. So we've got crest, trough, amplitude, and wavelength. So a lot of you juniors, I'm hoping this doesn't seem like a gigantic mystery because I know you're doing a little bit of trig in your math classes, at least if you have CPR, and so I'm definitely going to be borrowing very similar language. And although we may not be doing an explicit, huge exploration of trig in this class, definitely going to be taking a look at some of the same concepts. So I feel like I said definitely in a really weird way in this video. Okay, I'm going to not edit that out. So waves P and Q have the same, oh, look at that. They kind of line up like that. So they definitely have the same wavelength. But P has twice the amplitude. Meow. Okay. Waves Q and R have the same amplitude. But wave R has twice the wavelength. Yeah. Okay. Wave. Which wave shows a steady frequency but changing amplitude? I would say wave T. Now, what shows a steady amplitude but a changing frequency? Definitely S, right? Nice steady amplitude, but the frequency kind of stretches and shrinks. Waves. Let's see, we need a low amplitude and steady frequency. I would say Q and R. All right. So a wave has a wavelength of 2 meters and a speed of 5 meters per second. What is its frequency? Lambda V. We're going to keep this real simple for this test because in our next test, right, and on your final, we're really going to be exploring waves a little bit more thoroughly. So here we've got 5 meters per second equals 2F. So the frequency is going to end up being 2.5 hertz. All right. So that's the third page.